Hello and welcome to another video. I'm going to be explaining what the binomial distribution is. Now, the binomial distribution is just a technique and just a way to make probability exercises in a faster way. What do I need to have one? Let's start off with that. Well, I need something that it can be one way or the other. I can't have something that might be this way, or this third way. One way or the other, two possibilities. One way to think about it, something that can go right or wrong, like these things here. I need something that I know the probability that it goes right or wrong. Okay, I need to know what is the chances that I roll heads. That's going to be 1/2. What is the chances that in the dice I roll a 5? That's going to be 1/6, etc. And this is the important thing that I need for a binomial distribution. I need the events to be independent. What does that mean? It means that if I roll heads the first time round, right? I'm tossing a coin 6 times. First time round, what are the chances that I get heads? It's going to be 1/2, right? Great, 1/2. What are the chances that I roll heads the second time round? It's still going to be 1/2. The fact that I got heads in the first throw doesn't mean that there's a change in the probability of getting heads in the second throw. That's because the second throw is independent of the first one. So I need my trials to be independent. I need each time that I repeat the event, that I repeat the toss coin or the dice throw or whatever action it is that I'm studying, I need the trials to be independent. And I need them to have two possible outcomes. And I need to know the probability. When I have these three things, I am in front of a binomial distribution and I can use the following tool. But before we do it, explain to you some notation. How do we write all of this stuff? Because this is going to help you understand. So, not a very friendly way to write it. Okay, that doesn't look very good. This means something, okay, x, big X here just means something, think of it that way, has a binomial distribution, we're on the B already, okay, with these terms. These are the conditions of my binomial distribution. My conditions are going to be how many times do I perform the trial, how many times do I toss the coin, 20, 100, 15, and what is the probability that the event is right. 1/2 if I'm tossing a coin and I'm thinking of tails, 1/6 if I'm tossing a dice and I'm thinking of getting a 1, okay? And what I'm going to be finding out is how many times, if I'm throwing the coin 20 times, how many times, what is the probability that I get out of these 20 times, 11 times head, or 15, or 4, or more than 12? And I'm going to write it like this. Probability that this something is equal to 3, is equal to 12, is equal to 10. This is the way we write down and we express the binomial distribution. And if you're familiar with this way and you understand this way, it won't be that hard to understand the formula in your formula booklet. Here it is. Okay, so again, I have something that's distributed in a binomial distribution with n number of times the trial is done, p, the probability that the event is right. If I want to know how many times, what's the probability that this something happens, r number of times, I just put the values in the formula and I'm going to get a probability, which is great. However, it's not a very user-friendly formula. It's not that easy to work this out, right? So most of the time you're going to need a calculator to do this. But most of the time, if you have the calculator, you won't even do this because you will have a nicer way to solve this exercise. By the way, if you don't remember, this thing here is the, you should have seen this. You also have this in your formula booklet you should have seen it with the binomial expansion. Great. So again, you are supposed to know how to solve this without a calculator, but most of the times you are going to have a calculator. Before we show you how to solve it with a calculator, let me do an exercise with you. Okay, here's an example question. So I'm playing a board game, right? And I'm waiting for my turn, and there are 3 players. They're going to be throwing the dice before my turn comes. And here's the situation, you know, whatever it is, I have my cards in my hand, I'm waiting for this great chance. If 2 of them get a 4, I win the game. If 1 of them gets a 4 or none of them get a 4, then I don't win the game. And if 3 of them get a 4, something happens and I don't win the game either. So I need exactly 2 of these 3 people to roll a 4. Okay, do you get the situation? Great, so let's build the tree diagram. Let's forget about this binomial distribution stuff and let's build the tree diagram. I hope when you see the complexity of it, you will understand the advantages of the binomial distribution. So first player, okay, there are 3 players throwing the dice. Let's go for the first one. They roll a 4 or they don't roll a 4. What are the probabilities? Here they are. Great. Next player, either they roll a 4 or not a 4. So the first player maybe rolled a 4, then goes the second player. Maybe they roll a 4, maybe they don't roll a 4. What are the probabilities? We'll see in a minute. Also, if the first player did not roll a 4, well, I'm going to have the same thing. Second player rolls a 4 or doesn't roll a 4. So now, what are the probabilities? They're the same, because the trials are independent. The probability that the dice gives me a 4 is the same one. It doesn't change. So now let's go for the third player. So there's a 1/6 chance that the third player rolls a 4. But if he rolls a 4, then I have 3 4s. And that's not good, because I need exactly 2. If the third player in this situation does not roll a 4, then I have 2 4s, which is good for me, because that's what I need. Great. Here's the next situation, and the next one, and the next one. So to find out the probability of there being exactly 2 4s, I do 1/6 times 1/6 times 5/6, and I get a situation that's good for me. This times this times this, and I get a situation that's good for me. This times this times this, and I get a situation that's good for me. Add all the 3 results together, and I get the probability. You should be familiar with this. We've done something very similar to this with tree diagrams. So that's how you would do it with tree diagrams. But of course, that actually takes quite a long time. And if you think about it, if I was going to throw the dice 8 times, it would be brutal. It would be horrible. It would be a massive tree diagram. So this is where the binomial distribution comes in handy. Because all I have to do is put it in the formula. Because it's a binomial distribution, the events are independent, one way or the other, and another probability. So I'm going to roll the dice 3 times, and the probability that I get a 4 is 1/6. And I need it to exactly happen 2 times. So I just go to my formula, and I put it in. Solve the formula, and you get the probability. Great. Now, how do I do this with the calculator? Because, of course, that calculation that I had earlier on, not that easy to do without a calculator, right? How do you do it with the calculator? Well, you will most of the time have the calculator next to you, so frankly, this is the important part. So you press second and vars to enter the distribution menu. We're going to be using the distribution menu for a while. You scroll down the distribution menu and find Binom PDF. We're going to be using Binom PDF and we're going to be using Binom CDF, but I'll explain Binom CDF later. So you scroll down to Binom PDF, right? Here it is, and the following screen pops up. Now, the values that I've included here are, well, I throw the dice 3 times, and the probability is 1/6. And I want to get exactly 2 results. I want to get exactly 2 4s. I want the event to be correct twice. No more, no less. So I just press enter data, press paste, press enter again, and I'm going to get the same solution as I got before. So that's how you do it in the calculator, much quicker. Frankly, this is how you will be doing it most of the time. Thank you very much for watching, and I will see you next time. Goodbye.